Namaste. A very warm welcome to the 10th session, teachers.
We are in the last session. Finally, we have reached the last session. And today's is definitely going to be very interesting for all of you, which I don't think some of you would have come across. All the other sessions had been general, based on how a maths class could be, how it can be effective, and what are the tools we need to make the class interesting. And it is relatively more about syllabus, curriculum, portions, blueprint, question paper, everything, etc., etc. This session is differently an interesting one because it is just a different perspective of looking mathematics. Because I know some of you have come across basic mathematics. If not, in this session we will have brief knowledge about what is Vedic mathematics, how it can be taught to the children, and what are the benefits that Vedic mathematics gives us, and of course what is the main differentiation between the ancient mathematics and Vedic mathematics. And teachers, we all attended a 10-day workshop in our school. It was also conducted on by Mr. Vinay.
Good morning, ma'am.
Yes,
Good morning, ma'am.
Who was an eminent person in imparting Vedic mathematics to the children and especially to the teachers. So this year, not this year in the sense 2021-22, in our school, we started inculcating Vedic mathematics as a part of our syllabus for classes 5 to 8. And initially we started with simple sutras for class 5, class 6, and it went on to a difficult ones and how it could be solved in a easier way. And of course we gave them a booklet for class 5, 6, 7 and 8. A booklet was given to them and it was shared. In fact, it was not a hard copy because last year we didn't have the offline sessions in the beginning of the year. So it was given as an e-copy to them so that they can make use of it whenever needed. So actually those booklets were also prepared by our own teachers after attending the workshop. We took the relevant ones that will suit our children and it will cater to the needs of the children in a different in a class of heterogeneous children. That's what we would like to share. And of course that booklets will be of great use to you all. And from that booklet only we have taken some of the samples and we are sharing it with you. And teachers, I request you all to cooperate in this session and take up the session more interesting, because it is definitely an interactive session, and this session would not be complete if there is no interaction. Because when we took this session from our side, when our teachers attended the session which was conducted by Mr. Vinay Nair, it was of course a two-way process. It was only then we also could learn and we can make others learn. And that was the idea behind this, because as teachers, we all know when one side it is just gone talking, it will not be of any use, or it won't be effective, because I need to know what is the understanding part that has happened on the other side and whether it is interesting or not. So please make it an interactive session. And as I requested, it would be greatly appreciated if your videos are on, at least on this on last day. Never mind if you could do it for at least some few hours, it would be definitely an interesting one. And of course we will also feel happy that we are teaching only to the teachers. Thank you.
Thank you. So welcome, teachers. Welcome to this session of Vedic mathematics. So as we all know, I think as math teachers also we must be very proud of our rich culture, which was very strong in mathematics. So we always think the Western look up to the West for everything, and even teach students that say for example, who discovered the earth was round, the Greeks discovered, the Romans discovered. But if you see, even from the mythical times, we call the earth was called as gold, which means a sphere. So maybe we have not documented it, but we always had the understanding that the earth was a sphere since medieval times, ancient times. So our culture was very rich in science, math, and astronomy. And as math teachers, I think it's our duty to pass it on to the students and not say that this is something that was brought to us by the West, and we projecting our culture as something as math illiterate, and all these complex things were brought to us from the West, and it is because of them that we are progressing now. So as math teachers, that's very important to pass on to the children about our rich culture in mathematics. So this is just a brief thing I've shown you. So from the 3rd century BC, we have the Brahmi numerals, which you can see is somewhat the shape of the numerals which we are even using today. So it is from us that it has passed on to the Gulf countries, and from there to the Western countries. So ours is it has been the cradle civilization which has used numbers. So on a brief note, this is the 7th century mathematician and astronomer called as Brahmagupta. So he was from he was the chief astronomer of the king of Ujjain in Rajasthan, and he wrote a book called Brahmasputra Siddhanta, where for the first time he has used the concept of zero. The first time he has used the concept of zero, he has used the concept of negative numbers, and he was the one who did a great deal of development in mathematics. So after his use of the concept of number and treating the number zero in its own right, did mathematics progress a great way in the world to which we see it now. So all the credit goes to Brahmagupta for his initial discovery of all those very, very important concepts of integers and concept of zero, and of course a whole lot of other things, which if you are interested, you can Google about this great scientist called Brahmagupta and his work on Brahmasputra Siddhanta. And now we come to Vedic mathematics. So Vedic mathematics is by yogi called Bharati Krishna Tirtha ji, who we assume has taken the mathematics concepts called sutras. So it was all written in a very poetic way, like Tirukural we all know has two lines. Yeah, so in a very terse way, isn't it? So although these mathematical concepts are also expressed in sutras and upasutras, and from he claims has taken from Vedas like Atharva Veda and Rig Veda, and all these texts are rich are taken from the Vedas, what Bharati Krishna Tirtha says. So this is why the name Vedic mathematics is given to his way of teaching mathematics. So what is the benefit of using mathematics? We could all see before going into the actual concept of Vedic mathematics per se. So use of Vedic mathematics is it can help in simplifying calculations, enhances ability for numbers, improves focus, memory, and concentration. Definitely it improves the speed and accuracy. So all these concepts children can use in competitive exams or even during exams, because if you see only the calculating part, the children are taking a long time, and sometimes even the method is correct, the problem is wrong because of the working out part. Sometimes if it involves a very long division in a word problem, children just give it up because they think the procedural part of multiplication or division is very difficult. And of course, quick learning. There are a lot of sutras, 16 sutras and a lot more upasutras, but it is not possible for us to cover everything in this one session. So we are just giving you a sample of a sutra. So we will just begin with the first one. The first one says Ekadikena Purvena. Ekadikena Purvena is
It
the
is a
first
Sanskrit sutra, teachers. It is a Sanskrit sutras. All the sutras are written in Sanskrit.
Sanskrit. Yes. So this is
Ekena Purvena.
Ekadikena Purvena. I think people who are proficient in Hindi can broadly understand what it means. Eka means one. Eka means one. Adikena. Adikena means more, isn't it? So it is
In
one
Tamil also
more.
we say Adhikam. It's very simple. Ek in Hindi it's one. Adhikam, we say Adhikam. Adhikam in Tamil means more.
One. Yes, more.
Purvena means previous.
Yes,
Purva.
Purvena. Purva
Purva
means
in
always,
Tamil
yes,
also means Purva in Tamil also means the previous.
previous one. So it is
Those
one,
words.
it is one more than the previous one. And the so that is what we have explained it here. You can read it later. So if you want to tell it straight away, the first sutra we are going to deal with is Ekadikena Purvena, which is one more than the previous one.
Very simply worded. Eka Dikena Purvena means by one more than the previous one. So one more than the previous one is just what is the number one more than that. That's all. But where are we going to use this? That is very important. So actually we are starting with class 5 teachers. This is the sutra that we are teaching for class 5. Initially it starts with this only. Yes, ma'am. Ma'am, I would like to share one PPT, ma'am.
Yes, ma'am. Yes, ma'am. Now, ma'am.
Very simple. Yes, ma'am. So that I think they will have a brief idea as to why it is being taught. Can you make me as a host, ma'am?
Yes, ma'am.
You can make me as a co-host.
Yes, ma'am. Yes, ma'am.
Yes, ma'am. Just a minute.
Will I stop sharing, ma'am?
No, ma'am. Just a minute. I'll just.
Okay. Okay.
You can stop sharing, ma'am.
Ma'am?
You can stop sharing.
Yes, ma'am.
Just. I think, but I have lost yours. I'm able to. Okay. Somehow something has gone wrong.
Shall I continue and maybe if you're ready, you can share?
I'm getting it, but I'm not able to share. I don't know why. Have I to come out of that? Okay, ma'am. Sorry, PowerPoint can't read. It's just what it is saying.
Shall I continue with?
I'll just do that once again.
Yes. Yes, ma'am. It says I'm viewing your screen.
Okay. Viewing your screen, ma'am. Are you able to view my screen? That it is showing that desktop.
Yes, ma'am.
Yes, ma'am.
Vedic mathematics. Yes, ma'am.
But it is not opening. Okay. And now, ma'am?
No, ma'am. Just the desktop screen is there.
It says your screen sharing.
Yes, ma'am. Screen is being shared and we are seeing your desktop screen.
Oh my God.
It is standing on Vedic mathematics.
Oh, is it that?
Yes, ma'am. It is standing on the Vedic mathematics file.
Ma'am, you just need to first open that particular
Just
presentation.
I got it.
Yes,
I got
ma'am.
it now. Now, ma'am?
Yes, ma'am. Yes, ma'am. Yes.
This is just to brief you all about Vedic mathematics teachers. So, just a brief introduction about what ma'am has given. This is a collection of techniques or sutras. It can be named as techniques also to solve arithmetic problems in an easy and faster way. Actually, why is it all framed? It is actually, we feel that in many circumstances, it is very difficult to solve problems in a quick way because these quick means are only the things which make math more interesting. So, but where are we going to use this? This can be used in various mathematical problems, not only in addition, subtraction, multiplication, division, even in algebra, even in calculus, and even in exponents and powers. So it consists of 16 sutras, which we call it as formulae, and 13 upasutras, which is sub-formulae, which can be used to solve various math problems. And it was discovered by Jagadguru Sankaracharya Swami Bharati Krishna Tirtha between 1911 and 1918 AD. So that's what ma'am also shared with you. So ma'am was talking about Brahmagupta. India has been credited with some advanced mathematical discoveries at a very early time compared with the rest of the world. That's what ma'am was also sharing it with you. When we always compare with the West and we feel that we haven't achieved much. But the fact is that we have...
Ma'am's sharing has stopped.
Oh my God, what happened suddenly?
Yes, ma'am. Yes, ma'am.
So India has with some advanced mathematical discoveries at a very early time compared to the rest of the world. So it is a matter of great pride and honor for all of us that the early proponents of modern mathematics were jewels from India like Aryabhatta, Brahmagupta, Bhaskaratu, Srinivasa Ramanujam, to name a few. Of course, we are proud enough to say that we have included some of the Vedic mathematical sutras in our in-house publications wrapper also. And we have made it a point that children should be comfortable with Vedic mathematics because they need to know why it is being introduced at a very early age, because to make math more interesting and comfortable, because it is very easy. Then now, teachers, this is a question for you. How far are you all comfortable in multiplication by 2-digit, 3-digit and 4-digit numbers? As teachers, we all would say, why should I simply do that? Always there is a calculator in front of me. But for children, 2-digit multiplication is of course easy for them. But 3-digit, okay. But 4-digit numbers, when it comes to 4-digit numbers, they don't feel that ease when they are doing 3 and 4-digit numbers. Yes, teachers, would you all agree on that point? Yes, till 2-digit numbers, they are okay. But when it comes to 3 and 4-digit numbers, they are not very comfortable, right? Now,
yes, ma'am.
Multiplication concept, suppose if you are going to start with multiplication of this 2-digit, 3-digit, 4-digit numbers, children have to be definitely thorough in the tables. Otherwise, it is not possible for them to master over the multiplication concept. So multiplication tables forms the basis for them. So now let us look at the 9th table. What pattern do you observe in this table? Teachers, this was a discussion that was in our first session of Vedic mathematics. Just imagine you are a children in class 4 or 5 and then come out with the patterns that you stable. Teachers, feel free, of course, know some of the patterns already that we have given to the children. Yes, ma'am.
The multiple goes from, okay, Divya ma'am, use.
Okay, no, ma'am.
Any one of you, no issues.
Okay, ma'am. Ma'am, one's digit is descending and the 10th digit is it's ascending, ma'am.
Okay, fine. So the ones digit is descending. You're meaning in the product. Am I right,
Yes,
ma'am?
Yes, ma'am.
Right. In the product, the ones digit is in the descending and the tens digit is in the ascending order, right? Yes, ma'am. Yes, ma'am. Anybody else?
Some of the 2 digits are 9.
Sum of the 2 digits are, I mean the product, the sum of the 2 digits come to 9, add up to 9.
Yes, ma'am, sure. That is one of the major concept that we have to teach the children because they cannot go wrong in the 9th table. The sum of the digits in the product should be equal to 9. Should be. Yes, ma'am. Then, ma'am. There are lots and lots. Just think. Yes, teachers. Anything else?
In tens digit, the product that in tens digit, before number, ma'am. If it is 9 into 1 means 1 before number is 0. 9 into 2 means 2's before number is 1.
Super, ma'am. Yes, ma'am. See here, when we are, what she's saying is, when the multiplier, when you look at the multiplier, if it is 1, the tens digit should be 0. If the multiplier is by 2, the tens digit should be 1. If the multiplier is 3, the tens digit is 2. Yes, ma'am. Very good. Next.
The ones place is 10 minus.
The ones place is 10 minus. Yes, ma'am. Superb. That is also one of the see here. The multiplier is 1. 10 minus 1 should come in the ones place. 10 minus 2 should come in the 1. 10 minus 2 is 8. It is in the ones place. 10 minus 3. 10 minus 3 is 7. 10 minus 4 is 6. 10 minus 5 is 5. Yes, ma'am. Yes, ma'am. Look at the product once again, ma'am. You will get some more. There are lots of patterns that we observe in the 9th table. Look at the products. Up to 5 what it is and up from 6 to 10 what it is.
Tens digit, the cross, the multiplier, right? 1 is in the cross 1, ma'am. 1. Second, 2 is
Reverse order, ma'am.
reverse.
First 5 numbers and the
Yes.
remaining 6 is the reverse pattern.
Yes, ma'am. The digits are interchanged. The digits, ones digit and the tens digit is interchanged. Yes, ma'am. So now I have just highlighted, as ma'am said, the first point is for children. They would immediately identify that the tens digit is in the ascending order and the ones digit is in the descending order. Okay. Now let us come to the usual method of 2 digit by 2 digit multiplication. This is what we teach in our class. Am I right, teachers? This is what we expect from the children also. Yes? 32 into 99. We ask them to do the step first. Of course, 9 4s are 36, carry over. Then again, 9 3s are 27. They write and they find the answer. So it involves 3 steps. But before that, if they don't know the 9th table, gone. So now, how to simplify this? For this, we should know some 2 new terms that we have that we are going to learn in this session. One is Aquilam and Niquilam. So here, if you look at this, I'm just taking all the numbers that is being either subtracted from the smallest 3-digit number or added to get the smallest 3-digit number. I think all of you can do this very easily, teachers. Yes. For children, will they take so much of time? Right?
Teachers, please have a paper and pencil so that you can also work out and give the answer.
184 and 42.
Yes, ma'am. So here, either my minuend is 100 or my sum is 100. we will come back to that why I have taken it as 100. This is just to give an introduction like what I'm going to start with today. So you just look at it, because I have been talking about 2-digit number. I have taken the smallest 3-digit number. Either I'm getting the sum as 100 or my minuend is 100. Right. Now, ma'am will screen share.
Yes, ma'am.
Keep this point in the mind. I'll come back to that when we are talking about that. I said 2 new terms, Aquilam and Nikilam. Just keep that in mind. Now we'll come back to this sutra. Eka Dikena.
Ena Purvena. This is one more than the, which means it's one more than the previous one. And the other one.
Antayor Dashake Api. Antya means anti, we know. I think all of you know, ma'am. Please go back to that.
Yes.
Antya means last. In Tamil also we say antya, anti. So it's last. Antyayo dashake api. It has to be read like that. Dasha means, I think all of you know, it's 10. Das in Hindi is also 10. Dasha, it's 10. Dashake api. So sum of the last digits is 10. Here we have mentioned it as last digits. Actually, it should be one's digit. The sum of one's digit is 10. And what are we going to do using these two sutras?
Yes, this is the sutra under which this is the Upasutra. So let's see how to use these two to solve the problem. So what is the first condition? The condition of sum of the digits in the units place must be 10. And what is the condition 2? The digits in the tens place, the digits in the tens place should be the same number. So to be clear, we will give you some examples. So this sutra is applicable to find the product of any 2-digit by 2-digit number which meets the above conditions. So
now
look at the...
all of you can relate why I started with 2-digit by 2-digit multiplication. I think
So
now
what is the pattern you can see in these two numbers, teachers? We have given a couple of numbers. What is the pattern you can see here?
is the condition.
These two numbers.
And the sum of the ones place is 10.
Yes.
The
Yes,
tens
very
place is
good.
10 here.
Yes.
Yes. The
Plus
sum,
Look
yes,
at
see,
the-
sum of these two numbers is always, sum of the ones digit is 10.
10.
And the tens place is always the same. See, for 5 plus 5 is 10, 4 and 4 is same, 3 plus 7 is 10, 3 and 3 is so. This is the pattern. So how do you multiply numbers like this using the sutra? So 52 into 58. When Antaryo Dasakepi, that is the last digit is sum, makes the sum of 10 and this tens place remains the same. How do you multiply the digits? So the answer here has two parts. The answer for this sum has two parts. So first portion will be the product of these two numbers, which makes 10, which will be 2 into 8. Is this clear, teachers? So the sum will be of two parts. The first part will be the product of the ones digit that makes up 10. And here the second part will be this, the number which is already there and one more than the previous one. Isn't it? One more than the previous one. So what is the number previous to the ones digit, which is the tens digit? So
Ma'am, you
it
have
is
multiplied
one more.
5 into, ma'am.
Yes, ma'am.
Showing 5 into 5 plus 1. Yes, ma'am.
Yes, ma'am. So, so the answer. So it will be 5. So first portion will be 5 into 6. And then we all know 2 into 8 is 16. So what is 5 into 6? It is 30. And 2 into 8, 16. So the answer of 52 into 58 is 3016.
Got it, teacher. Just see, first is to check whether it satisfies both the conditions. First step is check the units place or the ones place whether the digits add up to 10. That by looking at itself, everybody can do, even children can do. Then look at the tens place whether it is the same. And now start applying the sutra. Multiply the units place, write it in the right side as usual. Then look at the tens place, one more than that. One more than 5 is 6. So 5 into 6 is 30. That's all.
Shall we do the next? Shall we do the next one, teachers? 45 into 45. So how
I think
can
teachers
we...
will do, ma'am. I think
Yes,
teachers
ma'am.
will give us the answer.
Yes.
Done, ma'am.
Yes, ma'am. Tell me, ma'am.
2025.
Yes, ma'am.
Yes, ma'am.
2025. In case the other teachers who have still doubts, I will just do it here. So first condition, 5 plus 5 is 10. Yes. So the first part of the answer will be the product of these two numbers, 5 into 5, which is 25. And then this part of the answer will be one more than the previous. And what is the previous number here? That is 4. And multiply with one more than the previous one. So that will be 4 5s are 20 and then 25. Yes, can you tell for the third one, teachers?
1, 2, 2, 1.
1, 2, 2, 1.
Yes,
Very
ma'am.
good.
Ma'am, what is
7.
special about 1 2 2 1?
Actually, the numbers, the first two digits and the other two digits are interchanged.
What is it? ma'am?
Palindrome.
It has got a special
Palindrome.
name. Yes,
Palindrome.
It's a
Palindrome.
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 It's a palindrome. Yes, ma'am. So 7 3. So 7 3s are is 21. One more than 3 is 4. 4 3s are is 12. So 1 2 2 1. What is the answer for this, teachers?
72, 24.
Yes, ma'am. 72 24.
24.
Yes,
See,
6
in no
4s
time
are,
they are able to do it.
yes, 6 4s are 24, and then one more than the previous one. 8 9s are is 74. What is the answer for this one?
42.
09 last one.
42?
No.
0, 1.
42
Yes.
9.
So teachers, the
Ah.
answer must be of 2 digits. That is where you have to be careful. The second.
42 09.
Yes. So it has to be of 2 digits. So 9 ones are is 9. You will write it like this. It is 0 9. 9 ones are is 9. You will write it like this. It is 0 9. 6 into 7 is 42. So 42 0 9. 4,209. So always it's very important to note that this must be of 2 digits. Okay.
This is the main thing they have to note it down. 0 9. Many a times children, when they are doing it very fast, they'll skip off that 0. That is very important. And remember, this sutra, what we have taught, can be applied only for this kind of pattern. Not for all the other multiplication sums. There is a general rule for multiplication sums that is also there for 2 digit, 3 digit, 4 digit. But this is the simplest one which we can impart it to the children in the lower ages. That is in class 5, because in class 5 they would have already mastered over the multiplication concepts, because right from class 2 they are learning multiplication concepts by 2 digit, 2 by 1, 3 by 1 and 4 by 1 in class 3 also. So by class 5 they know what is the concept and what is the process they have to do the multiplication questions. So now if you introduce this in class 5, as soon as they come across such questions, they will apply that sutra and try to get the answer in a faster means. Yes, ma'am. So was it interesting, teachers?
Yes, ma'am.
Yes, ma'am. Go to the next one, ma'am.
So that is what we have explained here, teachers. Find the product of 52 and 58. So 2 and 8, here you can see it makes 10. So you multiply that and write it here. 16, 8 2s are 16. So the next one would be, 5 5s are
No, ma'am.
is here. Yes. So the next number would be into 6. So 5 6 is 30. So the answer is 3016. what is explained here. So teachers, can you just do all this and
Let us
give the
have a quick.
answers?
See, actually, the first
Yes.
part is easy, but
Do the second part
we have
also.
little bit complicated.
Yes.
For the children, once they are comfortable with this, we can go for this.
Yes.
They have to identify one of the digit in both the multiplicand and the multiplier, and also in the product.
Yes. So teachers, can you just do it, teachers?
Shall you have the answer for the first one? I think teachers will be quick enough to say that.
2 to 1.
Yes, ma'am. It is 2 to 1.
Second one is 2016, ma'am.
Yes, ma'am. Sure. 2016, right.
90-20.
1924. Yes.
And fourth one 6 to 1.
Yes, ma'am. 621. All right.
16.
Now you have to find one of the missing digit in the product of the first one.
First one 2, ma'am.
Someone is
First one is
Somebody
2,
has
ma'am.
unmuted.
someone is unmuted, teachers, please.
Ma'am, second one is 3, 9.
Challenge, ma'am. They have to remember the condition first and fill in the units place. First step is to fill the units place. So what could be the number that will fit in that units place in the multiplier?
1, ma'am.
1, because the
Below.
condition is 9 plus something to make up to 10. That is very important. So all
So here you should
number
put 1.
combinations. So here first step is to put 1 in the units place. Then next condition is the digit in the tens place should be the same. So
Same.
this
3.
should also
So
be
here when you put 1, you all know that 9 into 1 will be 09. So you can fill this first.
then in the tens digit you have to identify the digit is same. So what is this in the tens digit? It is
So the
3.
condition is
3.
yes. So it will be the same. So it will be 3. So when it is 1 more than the previous one, it will be 3 into 3 plus 1, which will be 3 into 4, that is 12.
Yeah.
Did you understand, teachers? Did you all understand?
Yes, ma'am.
So we are taking it to the next level. Once they have mastered
Third.
this sutra, they can always form puzzles, because puzzles keep them engaged, and it's a challenge for them. They are so engrossed in doing that they master over this sutra. Yes, teachers, next one automatically they have to apply the condition. So what?
6.
64 into 66
Yes.
is equals to
6
4.
and 2, ma'am.
Yes.
Yes, here
4,
it will
6
be
are is 24. Yes. And here, because
4 to 1.
8
7 and
adhikena purvena, 6 into 6 plus 1, which is 6 into 7, which is 42.
32.
and here teachers.
7, ma'am.
Right, yes, ma'am. 7.
And 7 to 2, 1.
Okay, yes, ma'am. 7 to 2 1. Correct.
Because it is 3, you have to find a number which together it makes 10. Because antaryo dasa. Okay, so here it should be 10. So here it is 7. It must be 7, so that the sum is adding to 10, which is the rule. And so now we got the two numbers here. We can write 7 3s are 21. So this is 21 here. And this is 8 and 8. So here it will be ekadikena purvena. So that will be 8 into 8 plus 1. 8 into 9, which would be 7.
Yes, ma'am. Next one.
Understood, teachers?
Yes, ma'am.
So this is the one sutra we have done. Let us go to the next one. So now the same thing you can do, multiplication of 3-digit numbers.
So the difficulty level is increasing slowly. It's not earlier when I showed the small PPT in the introduction PPT, multiplication by 2 digit was little easier, and they were also doing it with ease when they were doing the step process. But now we have given one simple method. If this condition could be satisfied, how can that be done in a very simplest way? Now comes the challenge of multiplication by 3-digit numbers. So the same sutra, ekadikena purvena, is applicable for multiplying a digit number with another 3-digit number, which satisfy the conditions of the sutra. So what was the sutra? Let us go back to the sutra. Ekadikena purvena. The second sutra, the Upa Sutra, is very important. Antyayor dashake api. So antyayor
Last
dashake. So the units place or the ones place should add up to
must
10.
be
So
10.
1 plus 9 is 10.
10. And these two numbers must be the same. So as we all saw, the product of the ones place will be the first part of the answer, and here it will be ekadikena. So 12 into what is 1 more than 12? That is 13. So that will form the second part of the answer, which is 156. You all understand, teachers? You can just listen to this and you can do the sums I have given below. So when you have a number like this, 395 into 395, the condition satisfies. 5 plus 5 is 10. So the first part of the answer will be the product of these two digits, which is 25. And ek adikena purvena will be 39 into 1, which is 40. So 39 into 40 is 1560.
It
So
would
what is the-
hardly take less than a minute to solve these sum.
So the
Can
yes, so
solve 3-digit by 3-digit. Definitely children go wrong because they go wrong either in the multiplication or rearranging the numbers properly in the ones, tens or hundreds place. Then finally when they add also, they miss out those zeros and they add it wrongly. So this is actually a simplest way which children can adapt. Actually these digits can be increased to 4, 5, 6, like that it can go on. So we are dealing with 2 and 3.
So this is the last and final answer for the problem. Hope you understood, teachers. Yes.
Yes, ma'am.
Yes. So why don't
So
you
solve these. You can solve these problems and keep it ready, girls. Ready, teachers. Sorry.
13221.
13221.
Yes, ma'am. First step is 3 plus 7 is 10. So 3 into 7.
Yes. So this is checked. 3 plus 7 is 10. So the first part of the answer will be the product of these two numbers, which is 21. Now the remaining number left here on both sides. So both must be the same. Left on both sides is 11. So ek adikena purvena. So 11 into 1 more than 11 is 12. How much is 11 into 12? It is 132.
32.
So the answer for 113 into 117 is 13,221.
The next one, teachers, of course, that is very simple.
15624.
15624.
Yes, ma'am. 15624.
6
Already
fours are,
12 into 13 is already in the above question itself.
yes,
Yes,
6
ma'am.
plus 6 fours are is 24. And then as students, we can copy 12 into 13 from here without doing. So it is 156. The answer is 15,620. This one is also very easy, teachers, because
11009.
1100.
10.
so always remember the product of the ones place has to be 2 digits. So when you get 9 and 1, which makes 10, don't just write 9, it will be 09. This is the one thing you have to remember. And this both have 10, so it will be Eka Adikena Purvena. So always keep telling for the students so that they internalize the sutra. So Adikena will be 1 more, which is 10 into 11, which is very easy. And it
And
is
that is very important for the children to learn the sutra also. Keep insisting them to learn the sutra also, not only the concept behind the sutra. It is very important for them to learn the sutra.
So the answer would be 11,009.
Ma'am?
Yes.
Ma'am, up to 5th standard, preferably till what table they will be memorizing, like till 13, 14 or till 12, ma'am?
Actually,
12.
Till 12, ma'am. Till 12.
12 till all tables 12, bottom across also till 12.
Till 12, okay.
So,
Yes, teachers.
interesting. Teachers, was it interesting?
Yes, ma'am.
Here,
Yes.
actually, they have done with simple one, 11, 12, 10 and all in the tens and hundreds place. Of course, we can increase the difficulty level for children. Say some 495 into 495. Of course, that 49 into 50 is very easy for them. So we can increase the difficulty level also.
Ma'am, I have a doubt, ma'am.
Yes,
Yes,
ma'am.
Ma'am, if it is for two numbers, if we have three numbers like 11, 12 and 17, and we have to multiply those three numbers, will this hold for that number also?
What, ma'am? 11?
12 and 17. So one's digit is 10 and the 10th digit is same for those three number also. So will it hold for them also?
I didn't get it. What is that number you're saying?
Yeah, just 1 second now.
It tells it's like this, ma'am. 11 into 12 into 17. So that here all the numbers are adding up to 10 and here all the numbers are same.
Which question, ma'am?
No, ma'am, she's asking a doubt whether we can use this to multiply numbers like 11 into 12 into 17. Three numbers where if you add all the ones digit, it's in 10 and all digits in the ones place is the same.
Okay, teachers, why don't you all try now? So she has given up the challenge.
11 into 12
Ma'am, take a
into
fresh
17.
page. Just go
Yes,
to a
ma'am.
fresh page. Shobna ma'am, you can just
Yes, ma'am.
So 11, she has given the question 11 into 12 into 17.
If you apply the
She is
Upasutra,
asking, can we apply? Now please tell me, ma'am, how will you multiply this into this?
if the answer is in two parts, it must be 1 into 2 into 7. And here it must be 1 into, which will be 2. And then 1 to 6. And B2, if you apply the sutra, you would get 104.
Teachers, are you getting it? Are you getting it?
No, ma'am.
That's what I was asking. Is
It is not 214, ma'am. The answer is 2244.
44? Yes, ma'am. The answer is 2244. That's what I'm asking. Is it possible for three numbers also?
No, ma'am, it is not possible. But there is a work behind that, which when we look at it very carefully, you will also find one pattern in that. But that is not possible in all the cases. That is not possible in all the cases. When you look at the thousands place, yes, it is right. But when you are multiplying by three numbers, you have to take 3 digits. There, when we multiply 2 digit by 2 digit, we were taking last 2 digits. We divided into compartments like right side and left side. So the right side should have 2 digits. Of course, it can be 2, 3, 4 also according to the number that we have. But here, when we multiply three numbers, when very carefully, you will have the compartment of having it as 3 on the right and 1 on the, or 1 or 2 on the left side. You look at it, you will know that.
Okay.
Actually, we can.
Yeah, sorry.
Actually, we can see the beginning number and the ending number are the same. So I think some pattern is we need to find
Yes,
only
there is
for
a pattern that we need.
only for 24, maybe 2 into 1 and 2 into 2. Then we will get 2, 4 and 4. So, but to generalize this, we need to do another problem and find out whether this
Yes.
pattern will work. Isn't it, teachers?
Yes.
So ma'am, this particular sutra holds for 2 number. It can be of any digit, but it should hold true for only 2 numbers, right?
Yes,
Not
ma'am.
multiple.
Yes, ma'am. Yes, ma'am. This is only 2 numbers multiplied together to get the product, satisfying these 2 conditions. All right.
So now next we come to the concepts called Aquilam. So just now ma'am said it in her PPT. So now we come to a new concept called Aquilam. So what does the word Aquilam in Sanskrit means? Complete. Aquilam in Sanskrit means complete.
Not only
So-
in Sanskrit, of course, in Tamil also, we say Agilam, Agilam, Agilam. We say it as Agilam. Agilam,
Yes.
is the entire thing. Entire is, of course, complete. The entire is complete. So it means actually complete. Here in mathematics, what is our complete? What do you mean by complete? Why is it called complete? So when we talk about this Aquilam here, for class 5, actually we cannot speak about the powers because they are not used to that powers. What are the powers? They don't know. Only in class 7, they learn about the powers and components, exponents and components. They learn about these powers. So here, what we are trying to say is, for a 1-digit number, 10 is the Aquilam. So what is that 10? What is that 10? 10 is the smallest 2-digit number. For that matter, we have to reframe the word for class 5 in such a way that for any 1-digit number, the smallest 2-digit number will be the Aquilam. Same way, for any 2-digit number, the smallest 3-digit number is the Aquilam. And same way, for any 3-digit number, the smallest 4-digit number is the Aquilam, and it goes on like this and so on. So it can be extended for n number of digits. So 1-digit number, 10 is the Aquilam. The smallest 2-digit is 10. Same way for any 2-digit, 100 is the Aquilam. For 3-digit, 1000 is the Aquilam. So here, if we teach this concept, it will be easy for them to take it further to solve the problems. So that is what I meant when I started that Vedic mathematics, a small PPT, which I shared it with you all. Either your minuend or your sum is the smallest 2-digit number. And I showed only 2-digit. It can be extended to 3-digit, 4-digit, 5-digit also. So there, 100, when I took 2-digit, 100 was the Aquilam. Aquilam in the sense, my complete number, what I am going to consider is 100. See, when you look at that, for a 1-digit number, 10 to the power of 1 is 10. For a 2-digit number, 10 to the power of 2 is 100. It is actually like that. For a 3-digit number, 10 to the power of 3 is 1000. For a 4-digit number, 10 to the power of 4 is 10,000. So it actually goes on like that. It is actually the powers of 10. When you look at that way, it is very, very simple. For 1-digit, it is 10 to the power of 1. For a 2-digit, it is 10 to the power of 2. For 3-digit, it is 10 to the power of 3. So, but this we cannot speak to the 5th standard child because they don't know what is powers. So we are putting it into the simplest way, own words, where it will be easy for them to understand what is Aquilam. They know what is the smallest, they know what is the 2-digit number, they know what is 3-digit number. So base is the another word which means Aquilam here. My base is going to be the powers of 10. My base is going to be the powers of 10. Now teachers, if you look at it, it is very important that child should have mastered over the subtraction concept. That is very, very, very important. Okay, so that is very important. Now, when you look at these numbers which we have given, can you identify the base for the following numbers? For 5, what is the base or what is the Aquilam?
10.
10, right? Because it is a one-digit number. For 5,057, what is the Aquilam?
10,000.
Yes.
Right? Because it is a 4-digit number, 10 raised to the power of 4 is 10,000, or in other words, for any 4-digit number, the smallest 5-digit number is the Aquilam. So it is 10,000. For 209,
1,000.
yes, 1,000. For 51,
100.
100. So first step is to identify what is the Aquilam. Now, whenever we talk about Aquilam, what is said it is complete, but what is that makes it complete? So that also we need to understand, right? What should be done to make it complete? All the numbers cannot be complete.
So for 5, the Aquilam might be 10. But what is that it makes to reach the Aquilam? That is one more 5. So that 5 plus 5 will be 10. For example, what is the Aquilam of 6? That is 10. What it needs to reach to the Aquilam? That is 4.
So
Isn't
that,
it, teachers?
teachers got it. What is Aquilam?
So what for 25, what is the Aquilam, teachers?
For 25.
100.
100, yes.
75.
So what should be needed?
What
or
is needed to make the to reach the Aquilam?
75.
75.
75. So that has got a name.
This is called as the Nikilam. This is
Nikilam.
the complement of Aquilam and is called as the Nikilam of 6. Aquilam of 6 is 10. Nikilam of 6 will be what it takes to reach to Aquilam. That will be the Nikilam.
So in simple, we can say a number plus Nikilam will give the Aquilam. That's all. Very simple. A number, any number plus the Nikilam will give the Aquilam. What is that? That is required to make it complete. So the number that we add to it becomes the Nikilam.
Nikilam.
In other words, Aquilam minus the number gives Nikilam. That I think all of us already know as math teachers. Aquilam minus Nikilam gives the number, or Aquilam minus the number gives the Nikilam. That is how we put it in other words. So now I think all of you are aware of what is Aquilam and Nikilam. I think would have got a broader idea of about how to go with Aquilam and Nikilam. Aquilam is nothing but the base, that which is complete. So here we are keeping the base as 10, 10 power 1, 10 power 2, 10 power 3, it goes on. So for a 1-digit number, it is 10. For a 2-digit number, it is 100. For a 3-digit number, it is 1,000, and it goes on like that till how many ever digits we want, we can keep the base. So the word Nikilam means that which makes it complete. Which makes it complete in the sense that which makes it Aquilam. Or it also means, in other words, complement. I think the word complement, if we introduce to class 7, they will understand it better because they learn complement and supplement. That is why for class 5, we give it in a simpler way. What is makes it complete? So what is the Nikilam of 1? It is 1 plus 9. So 9 is called the Nikilam. And what is the Nikilam of 76? The Nikilam of 76 will be 24. So just try these, teachers. The Nikilam of 2, come on, let us have it in a quick, rapid session.
8.
What is the Nikilam of 2? 8. Yes, very good.
Yes.
Then 55.
Yes, because 45, the Aquilam is 100. So 100 minus 45 would be 55.
Then 636.
Yes, so
Yes, ma'am.
Aquilam of 364 would be 1000. So what is the Nikilam is 1000 minus 364?
636.
636.
636. Nikhilam of 3, 10 minus 3, which would be 7. So the what of 27 is 100? The Aquilam. Yes, the Aquilam of 27 is 100. The Nikhilam of 989 is
11.
11, because the Aquilam is 1000. Aquilam would be 1000 and Nikhilam would be 1000 minus 989, which is 11. So did you all understand the concept of Aquilam and Nikhilam, teachers? Yes?
Yes. I think they are just nodding their head, so we can take it as an yes. Okay, we'll go to the next one now.
So now here we have a new sutra. Nikhilam Navatas Charamam Dasataha. This sutra, this is
Nikilam
used
Navataha Charamam Dashataha.
Dashataha.
Navataha.
So
Navataha
this
means Nava means, I think all of you know, it stands for 9.
Navaratri 9. So Nava is 9 in Hindi. Dasha is, again, you all know, it is 10. So Nikhilam means you complement. We all saw how Nikhilam is called as the complement. So Nikhilam, complement from which number? Nava, which means 9. You complement from 9. Charamam means in Sanskrit, which means last. So you have to, Charamam is the last. So last digit complement from Dasa, which means 10. So all other digits you complement from 9. The last one you complement from 10.
Very
So
simple,
this is-
ma'am. Just write a number. We will explain that.
Yes, ma'am. So
Say,
this
for
is
example,
the
you write
sutra.
736. Yes.
So now this sutra is used for subtraction. This sutra is used for subtraction. So when we give, always when you give subtraction with numbers on top and numbers at the bottom, children are able to do. Even when borrowing the numbers, when you want to give with some numbers, they find it easy to borrow because they do it easily. Especially when you give zeros like this, then they immediately panic because they have to keep borrowing from one end to the another, isn't it? So now for sums like this, we use the sutra. So what the sutra says, the last number, you write the complement of 10, which means you subtract this number from 10. 10 minus 2 would be 8. For all other numbers, you complement from 9, which is 9 minus 1, which would be 8. You all understand, teachers? So I think if we solve a problem, we will be more clear on how to do this. And this is if in case you have a non-zero number. What if you have a zero number? You can't complement from 10 and write here 10. So what they say, if you have a 0 in the number, then the number previous to that must be treated as the first number and apply the concept. Otherwise, you just put 0 there. You start applying the concept only when you encounter the first digit. Understood, teachers? So I think when we do a problem, it will be more clear for you.
I think this itself would be clear for them. Last from 10, the rest all from 9. That's
9. So for example, if you 100 minus.
No, ma'am, you don't take 100. Ma'am, you don't take 100. You go to
Yes,
736. You go to 736, ma'am.
1000 minus 736, ma'am.
Takes 1000 minus 736.
1000 minus 736. So now what is the answer without borrowing?
The last from 10. So what is that last that we are there? Last means they are talking about the units place. They are talking about the units place. So there that it is from 10. So 10 minus 6, 4.
So this you can't find the Nikhilam from using Dasataha. So 9 as the base, you complemented. So what is the Nikhilam of this? How much it takes
All
to
the
reach 10?
rest I'm all the rest from 9.
9.
The rest
So 9
from
minus 3, 6. 9 minus 7, 2. That's it.
That's all.
And because there is no number here, you don't even do here anything. So you just stop with this.
That's all. It's very simple.
Understood, teachers?
The last from 10, all the rest from 9. That's all.
So supposing what happens when we have 1000 minus 530. So what so when you
This is already
encounter zero in the zero somewhere here, you only treat the first number as the first digit and you start applying the sutra, which means here you put a 0. Here you start applying the sutra, which means for this number you start complementing from 10, which is 7, and here you continue previous numbers, you continue with 9. So 9 minus 5 would be 4. Understood, teachers? So supposing you have a very large number and you have so you have a number like this for which you have to do the subtraction. This would be 0, this would be 0. You would start applying the sutra only from all these numbers. So which means for this is the treat this as the first number. So find the complement of it for 10, and for all others you do it with 9. And then stop. Did you all get it, teachers?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am.
So this is the sutra. And this sutra is extended for multiplication. Multiplication.
That is the challenge.
Yes.
That is the challenge. That is why we started with 2-digit by 2-digit multiplication. Now you will know why it is used. So they are going to use Aquilam and Nikilam both together to find the answer.
Multiplication.
After that we will do
So now,
that.
yes. So here, teachers, you have a multiplication problem, 7 into 9.
Now we'll go to the meaning of the sutra, ma'am.
7 into 9. Yes.
Nena Purvena.
So now we use, you use the new sutra called Ekanyuvena Purvena. So Ek Adhikena means it was one more than the previous one. Ekanyuvena means one less. It is one less than the previous one. So Ek Adhikena Purvena we just saw. This is Ekanyuvena Purvena, which is one less than the previous one. So for example, this sutra is used for multiplication by, see here, teachers, it is for multiplication by 9, 99, 999. For all multiplication by 9, which is such a terror for children, we can use this sutra, which means what is the answer? For example, if you take 7 into 9. So first you write the Nikilam of this number. So what first to write the Nikilam, what can we do? The Aquilam is 10. So what is the Nikilam? The number to reach 10, which is 3. And then this is Ekanyuvena means one less. One less. What is one less than 7? That is 6. So the answer is 63. So there is two parts. One is the Nikilam part and one is the one less than the previous one part. So Nikilam is 3 and one less is 6. So 7 9s is 63. You can understand it better when we do a 2-digit number, teachers. So for example, see the sum here, 36 into 99. When we say 36 into 99, what is the Aquilam of 36? What is the Aquilam of 36?
100.
So what is the Nikilam? What is the Nikilam of 36?
64.
Yes.
So that will be
that
the
would be
the
first part of the answer. That would be the first part of the answer. And what is 1 less than 36.
35.
35.
35. So this is the answer. 3,564 is the answer to this problem. See, that's given here. Understood, teachers? I think when you can do some problems, you can be thorough. Yes. So here, can you
Actually,
do
the
these
same
problems,
sum.
teachers?
Ma'am, actually the same sum can be done in a different way also, applying the same sutra. Ekanyunena purvena.
Yes, ma'am. You
Ma'am,
want me to put the previous slide?
Ma'am, can you just put the same thing here? In 96, straight to that 96, you put a dash. So, no, ma'am.
1 second, ma'am. Yes.
No, that slide only.
Yes, ma'am.
Next slide only. So
Previous slide,
of
ma'am.
96. This only, this only.
Yes, ma'am.
Aquilam of 96 is 4. So put a dash and write 4 here, ma'am. I'll tell you.
Yes, ma'am. Yes.
Yes, teachers, I think all of you are clear about the Nikilam of 96 is 4. Yes, now come to what is the Nikilam of 99.
So this would be 0, 4.
1.
Yes, ma'am.
Yes, right, 1. 1. Now, just try to find the product of the Nikilam. Quickly, teachers. Let me see. There is a pattern in that also. This is usually done in various problems to arrive at the answer also. This is also one of the method.
0, 4.
What is 1 into, multiply both the Nikilams. 1 into 4?
4.
4. So, but it's a 2-digit number because our Nikilam is, sorry, our Aquilam is 100. So, 0, 4. That's all. So, the right side will be 0, 4. And then, see, in both the ways, if you see 96 minus 1 or 99 minus 4, cross and see the 96 minus 1 is 95 or 99 minus 4 is also 95. Can you look at that pattern also? Yes, teachers? Crisscross, crisscross subtraction. Ma'am, just put that crisscross subtraction and show, ma'am.
Yes, ma'am.
Either 99 minus 4 or 96 minus 1, both are 95. Can you see that, teachers? It's very simple. So the answer is 95. In any way, if you do, you will get the answer as 95. Actually, this is a simpler way to do. So you can try that for any numbers multiplying by the greatest 1-digit, 2-digit, 3-digit, 4-digit numbers. Here
Yes, ma'am.
Greatest.
Yes, ma'am. Maybe we can teach them that as a separate method, ma'am.
So
That we can teach as a separate method, because here once maybe they can do using the sutra and maybe next way they can use that.
This is the method that they have to apply, ma'am. Actually, below base. This is called below base.
Below base, yes, but this is using sutra, which they can do it also. So this
So there
is,
are a lot of patterns.
yes, that is what. Yes, ma'am. So there are a lot of patterns, teachers. So using the sutra, you can just do it like this. And using the above base, below base, I don't think we have explained to them. So
Sure.
so here, teachers, again 17 into 99. What is the Nikilam of 17? Aquilam would be 100. What is the Nikilam?
83.
83. Correct. So 83.
This would be 83.
1683, ma'am.
Yes.
So
So
one
what
less
is the number previous to that? That would be 16. So can you solve the puzzle, teachers?
The number is 57 into 99.
Very good. Because here it is 56, which is the would be the number before. Which would be the number before this. So here will be the number that comes after that. So that would be 57. And now,
5643, ma'am.
yes, what is the Aquilam of 57 is 100. So what would be the Niculum of 57?
43, ma'am.
That would
43.
be 43.
Yes, ma'am.
Here, teachers.
Just think it over. It is a little tricky one.
Ma'am, it's 26.
Yes. It's 26.
Yes, ma'am. Superb.
Then we have
Very good.
25 and
It's
70.
25.
Yes, 25 and
So here 26 means it should be 74.
74. How did you get this? Teachers, how to get this?
Which one?
Because we have 5 here, that means
Yes,
the
5
one
here.
we have 6.
Here the next number must be there. That is, so you put 6 here.
And because we have to get a number which comes in 70s, that means the number is more than 20 but not 30.
Yes.
So
Yes. Sure.
that's why we have 26 there.
Right. We'll go to the next one, ma'am.
Yes. So this again, the same concept you used to extending to 3 digits, which is 999. So if you say 316 into 999, so you take what is the Aquilam of 316, which is 1000. So now take the Niculum of it. What is the Niculum? 1000 minus 316 would be 684. And what is the previous number? That is 315. So this is the answer for this multiplication. Same concept, because it is 3 digit, you are taking the Aquilam to be 1000 and the finding out the Niculum, that is the first part of the answer. And then you are writing 1 less than the previous one. A Kannuvena Purvena. 1 less than the previous one, that is 315.
Go to the next one, ma'am.
And here
So yes,
also have a
teachers.
doubt, ma'am.
Yes, ma'am.
Ma'am, here the one number would be any of the 3-digit number or 2-digit number or maybe single-digit number, but the other number would be 9, 99 or triple.
Ma'am, not necessary.
No.
But actually here it says it is the greatest 1 digit, 2 digit. If you apply the method what I said, no, you can go
Above the base, yes, ma'am.
that is why.
But
Yes,
in
ma'am.
this case, whatever we have done,
To
we
finish
have
this,
done
ma'am, you finish this, then we will go into that also. That is so interesting actually. You can do that for any sum.
Any sum, yes.
Any-
Above the base method and below the base method, you can do for any sum.
any sum.
There
I think
are-
this you can close it and open that word, ma'am, a notepad, so that we will do that also. Teachers will have a broader view.
Yes, ma'am. After finishing this, maybe I can demonstrate it also, ma'am, using any 2 sums.
Okay.
Mm.
Yes.
Thank you, ma'am.
I think this is very easy, teachers. The Niculum of 428 is
572.
yes 572.
427, ma'am.
Yes, 427.
Here it is
That's all.
427.
In what to say? In few seconds, they are able to get the answer.
872 into 999. The Niculum of this is
128.
Yes,
128. Here it is 871.
871. And here already one part is given. It is 896.
So you can write what
The
comes
Niculum of
here.
896.
104.
Yes,
Yes.
Niculum of 896 is 104.
104.
And
So here
Aquilam is
obviously here
103.
103.
103.
Yes.
Super. And same way here, the Niculum of dash. It is 2 something. In something, the tens place is missing. And there. Actually, here the clue is there.
So here, this is the clue. So here
Hmm.
you take the
777.
700 here,
777.
777. So here it comes 776. Then of course you can fill it here.
So what is the Nikilam of 777? It is 223.
223.
Now you can that, ma'am, and you can tell the teachers. I think you have come to the last slide, right, ma'am?
Yes, ma'am. So I think we can tell that.
So give
quickly
it.
on.
Give the question as 92 into 98.
Yes, ma'am.
Give the question as 92 into 98. See here we have not done with greatest 1 digit, 2 digit or 3 digit number. We have taken
Yes, sir.
digits. 92 into 98.
Yes. So actually, before
What
going to
make-
that, we can even do it with a very small problem. For example,
92
any
into 97. Okay, here 92
any.
if you take it will be summing up to 10. So go
Yes,
for
ma'am.
92 into 97, ma'am.
Just a minute, ma'am. Before that, we'll just go into a very small problem. For example, if it is 18 into 19, so how much? So what is the base of this problem? It would be 10. How much it deviates from the Aquilam 10? If you say it is 8, how much it deviates from here? This would be 9. This would be 9. So the answer will have two parts. One is the product of these two. One is the product of these two, which would be 72. The other one would be from the base, you add all this 10 plus 8 plus 9. How much is that? That would come to, how much would that come to?
27.
27.
27. This would be the answer.
No, ma'am. No, ma'am.
No, sorry.
No, ma'am. It is actually a 1 digit number. Your right hand side should be one part. Only
Yes, ma'am. 7. Yes,
because
7.
your base is 10.
Yes,
Because your
yes.
base is
72.
10,
Yes.
7 is
And then
carried over.
27, and so this has to be one part. You carry over this here and you add it. So this would become 2, 4 plus 7 plus 7, 14. So it would become 340.
The easier method would be
Yes, ma'am.
like
You
this
tell
is
your
the
number, ma'am.
92 into 97.
92 into 97.
So teachers, this is below base. The number what ma'am gave was above
Above the base.
above the
Below
base.
base, you write.
It is closer to 100. That is what is below base and above base. Here it is closer to 100. So what is the Nikilam of 92 to make it 100? It is 8. And here it is 97 plus 3.
8 and
Right.
6.
Now the first step is to multiply 8.
Multiply. Yes.
Here my base is 100. So on the right hand side, when you divide it into two compartments, it should have 2 digits. Please remember that. When my base is 10,
Yeah.
when I divide it into two compartments, my right hand side should have only 1 digit. But when my base is 100, my right hand side should have 2 digits according to the number of zeros. That is very simple. So when it is here 8 into 3, it is 24. On the
24.
Ma'am, write it here, ma'am, below this. Make it into two compartments. Write it as 24.
Yes, ma'am.
So now either multiply 92 minus 3 or 97 minus 8. Both, what do you get? What do you get, teachers?
89.
Yes, in both the cases it is 89. So that is the answer. You can try this for any number of sums. Can you all try, ma'am? One more sum I'll give you. Yes, ma'am.
Yes, ma'am. Give me the question, ma'am.
I'll give you the question. It is 102 into 105. 102 into 105. Can you identify, teachers? Is it above base or below base?
Above.
Yes, it is above base.
Above base.
Above base in the sense it is just 100 more than. So my base is 100. So how much it is more than 100? The first one, 2 more than. So
It is 2.
the next one, it is more than 5.
5.
So first step is to multiply 2 2 into 5. Right, it is 10. Now what you should do, it is above base. So I have to add. So 100 plus 102 plus 5 or 105 plus 2. What's your answer?
107.
Yes, that's all. So in above base you will add in the below. So do one sum next to it as below basement so that they will understand it better. 89. Sorry, I'll make it as 899. Make it as 899. Let's do that, a difficult one. Into, say 900. 900. So now teachers, can you tell me, is it above base or below base?
Below base.
Yes, it is below base. So 899 is closer to 1000. Right. So what should it be added to make it 1000? 101. Right. 101. So now the first step would be multiply 101 into 100. So what would be your
10100.
But listen carefully. My right side should have how many compartments? Only 3. Right? Because my base was 1000. So I can have maximum of 3 digits. So that 100 will be written and what will be carried over? 10 will be carried over. Right, teachers? Ma'am, write that 10 separately, ma'am.
And that's what. I've shown that it should be carried over.
Now, what is that? It is below base. Subtract either 899 minus 100 or 900 minus 101. You get the same answer as 799. But this carryover should be added. 799 plus 10 will become 809. Then followed by 100. You can also check. Very simple. Yes, teachers got an idea? Right? This can be extended to any set of numbers. 3-digit, 4-digit, anything, even 2-digit also for that matter. Go for a 2-digit number, ma'am. I'll tell you. Below base for a 2-digit number. Go to the next page, ma'am. So 78. Say for example, 78 into 97. So is it above base or below base, teachers? Can you just tell me quickly?
Below base.
Below base. So what is the base for this? My base is 100. So remember, my right side should have 2 digits. So what is the Nikilam of 78?
22.
24, correct. 24.
22.
22.
22, sorry, 22, sorry, 22. 97, what is the Nikilam of 97?
3.
So my first step would be to multiply 22 into 3. So what is 22 into 3? 66. Right. Then either I can multiply 78 minus 3, sorry, subtract 78 minus 3 or subtract 97 minus 22, whichever is easy.
75.
Yes. So this is the answer, teachers. So it is a very easy way to find this can be done for any set of numbers. The same method can be applied for even the greatest numbers. So that one you can use only for the greatest 1-digit, 2-digit numbers. This method you can apply for any set of 2-digit and 3-digit numbers, either above base or below base. Remember, only thing is when it is below base, you have to subtract. When you do the crisscross, when it is above base, you have to just add. That's all. Very simple. Shall we do one more? 145. We'll stop with this. 145 into 110. Teachers, can you tell me? Is it above base or below base?
Above base, ma'am.
Yes, ma'am. Sure, it is above base. Above base. My base is
10, 100.
This 100. My base is 100. So it is 45 more than that, and here it is 10 more than that. So my first step would be 45 into 10. What is 45 into 10?
450.
But what should I write? Is it 450?
No, ma'am. Only 2 digit we have to take. Only
Because my base is 100. So that 4 is carryover. Now add 145 plus 10 or 110 plus 45. Both the base, what do you get? It is
155.
5. But this 4 should be carried over. So 155.
159.
159.
159.
159, 50.
950.
So I think all of you are able to get it, teachers. Ma'am, somebody has asked me 43 into 51, correct? 43 into 51. Ma'am, somebody has asked 43 into 51.
Yes, ma'am.
Right. Yes, ma'am. We can go for 43 into 51. Well, so teachers, ma'am, go to the next slide. Yes. 43 into 51. Question is 43 into 51. Can you tell me, teachers, is it above base or below base?
Below base, ma'am.
Okay. What is the Aquilam of 43?
57.
Yes, ma'am. Right.
51, 49.
49. 49.
49. Now look at that. Is it easy for you to find out 57 into 49?
No, it's difficult.
So is it easy for you, I'm asking? It will come up to 2793, correct? Yes, teachers?
Yes, ma'am. Yes, ma'am.
So,
It's 279.
this kind of sums, when you come across,
When they're
this method.
near to the base
Hmm.
or have deviated a little bit from the base. That is the pattern.
Yes. So these kind of problems, see here, whether you multiply 57 into 49 or 43 into 51, it is going to give you a long process. If it is the same like 43 into 51, rather than multiplying 57 into 49 and getting an answer, it is easy if you multiply 43 into 51 directly, or 50 plus 1, 43 into 50 and 43 into 1, then add both. That is so easy for you. Am I right, teachers? So don't advise children to follow blindly this method.
If the numbers are nearer to the base or have deviated little bit from the base, this method can be used wisely. That is why we say Vedic mathematics is not, the mathematics knowledge using of concept per se, but it only helps in faster computing ability. And that depends on identifying the patterns and using the correct sutra.
So what happens here is you get 2793 and you retain that 93 because it is below base 100. 100 is my base, so 2 digits 93. Here it is 2793. So we retain that 93 alone here, and that 27 is carried over. But when you look at it, it is 43 minus 49. When you look at it, 43 minus 49. Are you not getting it in negative? It is minus 6. It is minus 6. So what should we do? Already we have 27. So 27 minus 6 is 21. So that is your answer. So your answer will be 2193. to check it. So 43 minus 49 is minus 6, but already I have to carry over 27. So minus 6 plus 27 is 1. So 2193 will be your answer. Even if you apply the same concept, you will get the answer. Here I am applying the same method what I followed for the other sums. I am getting the answer. Am I right? But is it wise enough to do it in this way for all the sums monotonously? Not necessary. Not necessary. Still you get the same answer. Even if I apply the method. Can you just see, teachers? Yes, all of you, can you check? 57 into 49, I multiplied and I got 2793. But my base is 100. So I retained only 93. And 27 is carried over. So, but when I subtract 51 minus 57 or 43 minus 49, it is minus 6. So minus 6, and already I have carry over 27. So 27 minus 6 is 21. So my final answer is 2193. But it is not necessary to do this sum in this method. Yes, teachers, got it? So any sum for that matter, you can do below base and above base in this method to try. We have also some more sutras given for class 6, 7, 8 and 9 like oscillators and many other complex sums we have also done. So that we will have it if we have time in our next session. Hopefully the session was very interesting for all of you.